Infinity and beyond!
There are many ways infinity can be expressed. The most common way people view infinity is as a series of positive or negative integers extending out in infinite directions as represented on either a negative line graph or a positive line graph. However, infinity is far more complicated and prevalent than that. For example, let's look at the positive integers 1 and 2. Looking in between the two, we see that there are multiple numbers that aren't integers but are still real. Some examples of this include 1.1, 1.2, 1.3, 1.4, 1.5, etc. However, those aren't the only decimals that you can use as an example. If you move the last number into the hundredths place, you can get 0.01, 0.02, 0.03, etc. This time, if you keep adding numbers, you can keep making the decimals bigger as long as you want. However, you'll never run out of decimals. This is because there are infinite numbers between the integers 1 and 2, showing how common infinity is and how it's there and how you might not expect to find it somewhere.
If we were to rip this piece of paper in half, what would we end up with? Now if we rip these pieces in half again, what would we end up with? We could repeat this process again to form 1/8. Now you see where we're going with this, but each time we rip this, we're getting closer and closer to 0. Yet each time, we're never going to reach 0. This is infinity. We could cut this infinite times, but we'd never reach 0. Now let's go over some basic problems using infinity. In this example, we'll be using 5 pineapples added to an infinite amount of pineapples. What would we get? We would get an infinite amount of pineapples because there is an infinite number of combinations, meaning there's an infinite number of answers. This simple logic also applies to subtraction. Say we have an infinite amount of polar bears. Now when we multiply this by an infinite amount of polar bears, what are we going to get? As you guessed, infinity, because there's an infinite amount of polar bears, meaning there's an infinite amount of combinations. Wait, Charlie, what happens when you divide a countable number by infinity?
So glad you asked, John. When you divide a countable number by infinity...
Okay, sorry, after you're rudely interrupted, continue, Charlie.
Alright, when you divide a countable number by infinity, the countable number will be represented by a. Now when you divide that by infinity, as shown here, you might think you get infinity because everything else gives you infinity. But in fact, you get 0. Now why this happens is because the number we're dividing a by can increase to such high numbers, like a divided by 57 million billion or something. Now we just go to the limit of what things can be divided by, and we get 0.